Here in this question, two beads each with charge Q and mass M are on a horizontal frictionless non-conducting circular loop of radius capital R. One of the beads is glued to the hoop at some point while the other one performs a small oscillation about its equilibrium position along the hoop. The square of the angular frequency of the small oscillation is given by, here epsilon naught is the permittivity of free space. We need to find the square of angular frequency. Well, the system that we can think of is like, this is the particular point at which a mass m and charge q is fixed, and the other, it can move on this particular periphery. Let's say it shifts by a distance of x along this direction, then the force due to this charge will be acting in this particular way, and we can write down this force as q square divided by 4 pi epsilon naught, and this distance here to here, if I say this angle to be theta, this angle to be 2 theta, this one will also be theta, then this r from here to here, it will become 2r cos of theta. So r square will have the value of 4r square cos square theta. Got it? And yet again, this displacement x, it can be written as 2 theta will be equal to x divided by r, or we may write down theta as x divided by 2r. Theta is the angular displacement from this particular point. Got it? Now, if this is the force, then clearly this force will have a component, one along this direction, this angle being theta, so this one will be f cos theta, and the other, that will be the restoring force along this direction. So we can say f restoring, that will be f into sine of theta, and if theta is small, then sine theta will almost be approximated as theta itself. So here it will be q square divided by 16 pi, this 4 and this 4, epsilon naught r square, here cos square theta will be having the value of almost 1, and sine theta, here I am putting the value of theta, since sine theta will almost be equal to theta, as theta is very small, must be equal to force restoring, and it can be written as m into acceleration, that will be restoring acceleration, so there will be a minus or negative sign. Since I just wrote the value of theta to be equal to x divided by 2r, so I can write down the restoring acceleration to be equal to q square divided by 16 pi epsilon naught r square, here theta to be written as x divided by 2r, and this m will be here. So we can see here that this particular value, this one, is the value of omega square. So we can write down the value of omega square to be equal to q square divided by 32 pi epsilon naught r cube into m. Just see which one of the option is the matching answer. We can see that option B is matching with the calculation here. Got it? So we can see here the answer that is provided on the sheet. Well, option B is the correct answer for this question.